Good evening, all. Welcome to DSA with Python, day 5 training session. So, in today's session, we will talk about some of the programs which were asked in interviews using list data structure and some important logics. Generally, these kind of questions are very important for competitive programming. So, let us work out such kind of problems, okay, so that you will get some uh, idea how the questions will be asked in competitive coding. Nowadays, all companies are hiring through coding challenges only. Okay, so that means they are conducting an online coding test, then only selecting the candidates. Okay, so that's why you should able to solve questions on the online platform, and they are not regular questions. Okay, so let us look at some of those questions and we'll try to solve such questions today. Yeah, so today's first program is find the GCD of two numbers. Okay, so generally this question will be asked in interviews. This is very important question. Okay, so finding GCD of two numbers program, you should be able to write if asked in interview. Okay, so let us understand how GCD of two numbers can be solved using mathematics. Okay, so given two numbers like say for example 10 and 15. Okay, so we need to find the GCD. Okay, so what do you mean by GCD? Greatest common divisor. Greatest common divisor. Okay, so the meaning of this is that means all the numbers which divides these two numbers, among those the greatest number. Okay, so common to both, that means it should divide both the numbers. Okay, among those the greatest divisor that you should identify, that is called GCD. Okay, so let us find out what are those common numbers which divides both these numbers. First one divides both these numbers. Okay, then 2, no, 2 divides 10, but 2 does not divide 15. Okay, so then 3 divides 15 but does not divide this 10. Okay, so 4 also, so 4 does not divide this 10. Okay, so 5, yeah, 5 divides both of these numbers. Okay, so then 6, 7, 8, remaining all numbers. Okay, so up to 15 you don't get any divisor. Okay, so which divides both these numbers. Now these are the two common divisors. Okay, or in other way you can also say factors. Okay, so out of these two, the greatest divisor is 5. Okay, so this 5 is called as a GCD of these two numbers. Okay, that means 5 divides 10, 5 also divides 15. Okay, so this is called a GCD among all the divisors which divides these two numbers. Okay, so the greatest is 5. So this you need to identify. Okay, so if you work using this method, okay, so it takes lot of time. Okay, so there is a method in mathematics, there is a method to find GCD of two numbers. Okay, so how do we find in mathematics GCD of two numbers? That means we divide the bigger number with a smaller number. Yes or no? Okay, so 10 once 10 here, then we get the remainder as a 5. Okay, so then again we take this remainder. Okay, so then we bring this 10 here. Okay, so we take 10 here. So again, considering these two as numbers, again we proceed with the division process. Okay, so 5 2 times 10. Okay, so until we get the remainder 0, we go on continue this division process. Okay, so once when we get the remainder as 0, then the last divisor which divides this number. Okay, so this is called a GCD. This is called a GCD. Okay, so this is how mathematically, by using division method, we identify GCD of two numbers. Okay, so the same mathematics now we need to convert into programming steps. Okay, so considering the first number as a, considering the second number as a b. Okay, so that means given two numbers a and b, then you need to find the GCD of these two numbers ab. Okay, so this logic, this mathematics now will try to convert into programming. Okay, so you should understand how mathematics can be converted into programming steps. Okay, so the same kind of calculation now you ask your computer to do. Okay, so when it performs that computation, when you write program for that, then it performs the same kind of a division and gives you the GCD of these two numbers. Got it? Okay, so how we can write this function? Okay, so that you can define a function for this. Okay, so how we can define in Python a function by using def keyword. Okay, so def. Okay, so we call the function name as a GCD. Okay, so here we pass the two numbers a and b as arguments. We pass the two numbers a and b as arguments here. Okay, right? So let us take a value as a 10 and b value as a 15. A value as 10, b value as a 15. Okay, right? So now what we are doing, we are dividing. Okay, so we are continuing the division process up to what level? Until the remainder becomes equal to 0. Until the remainder becomes equal to 0, we are go on continuing the division process. Okay, so that means here we need to test. Okay, so we need to test here if okay, so a mod b, if a mod b is equals to 0, if a mod b is equals to 0. Okay, so when it is equals to 0, okay, so which number is considered as a GCD here? Which number is considered as a GCD here? Now see, a is 10 here, b is 15. Okay, so we are dividing b with a. We are dividing the b with a. That means we are performing a b mod a here. Okay, the meaning of this is divide b with a and gives the remainder. That is the meaning here. Okay, so in this case, now this is the last step in our division. This is the last step in our division. Okay, so 5 and 10. Okay, so which is a and which is b in this case? Which is a and which is b in this case? Okay, we are always dividing b with a. Okay, so that means we are dividing 10 with 5 here. We are dividing 10 with 5 here. Okay, so in that case, a becomes 5. Okay, then b becomes 10. B becomes 10 here. Okay, so now see here, if a is 5 and b is 10. Okay, so when you perform b mod a, okay, so that means what we are doing here, b mod a. Okay, so you write here b mod a here, otherwise b mod a. Okay, so if b mod a is equals to 0, okay, so b mod a is equals to 0, divide b with a and give the remainder. If it is equal to 0, now which one is the GCD here? Which one is the GCD? This 5 is present in which variable? A. Okay, so that means you need to return a here. A is the GCD. A is the GCD. Okay, so otherwise what happens? Then you should go to the next level. Okay, so we'll take the first level and how it changes the values of these a and b. Always it is a and b only. You need to interchange the values. Okay. So what happens in our first case, we will see here in this case. Okay. So I'll write this clearly. If b mod a, if b mod a is equals to 0, okay, then say return a is the gcd, that value we are returning here. Okay, so in our case we'll take the first step here, a value as a 10, b value as a 15 here. So what happens, b mod a, 15 mod 10 here. Okay, so this first step, 15 mod 10, what is the remainder here? That means divide 15 with 10. Okay, so then get the remainder. What is the remainder we'll get here? We'll get the remainder as a 5 here. So is it equal to 0? No, then it comes here, it comes here. Okay, so it comes here. Then again you should continue the same division process. Okay, so how you continue the division process? By considering the remainder as a, and then previous a value now becomes a b. Okay, so then you are taking this 10 here, you are taking this 10 here. Okay, so remainder becomes a here, remainder becomes a. Okay, so that remainder becomes a value, and previous a value becomes previous a value now becomes b here. Okay, so you need to interchange these values. Okay, so then only again the same process continues. That means it should continue the same division process. Okay, so this you should do. So gcd, to find the gcd, who is finding the gcd? This function is given a and b value, it is calculating the gcd. Okay, now for these two numbers also, again, instead of writing the logic here, now you pass these two numbers again, a and b, to gcd, it will take care. So that means what I do, I call the function again here. This is called recursion. I call the function. Okay, so gcd function again here, but this time I need to pass a and b values. What are my new a and b values? What are my new a and b values? This remainder is my new a value. The first argument what I should pass is the remainder. That means b mod a I should pass. Okay, then the second argument b I should pass. Okay, so which is b here? Previously a value. Okay, so previously a value now becomes a b value. Okay, so that means previous a value I should pass to the function. Okay, so that means within the gcd function I am calling the same function again with new arguments. This is called a recursion. Okay, so this is called as a recursion. We will discuss this recursion, but this gcd program can be solved efficiently by using this gcd. Okay, so same mathematics, what how I am doing this mathematics here. Okay, so the same mathematics now I am asking my program to do. That's it. Okay, so then what it does, it performs the same thing. Okay, so that means the function will be called here, the function will be called, and you will get some value here, return value, no, so that you can write here. Okay, so otherwise what you should do, you should say calculate a GCD for these two new values and return that value. That is what we should inform. Okay, so how it calculates, now see here. So again the same function will be called, but this time now it is just like calling another function like GCD. Okay, so what is the first value? First value is 5, and what is second value? 10 is the second value. Okay, so that means this becomes a new a value and this becomes a new b value. So again the function will be called, again this function will be called. Okay, so when this function is called, again it enters this and it checks this if condition. Okay, so what it does is checks, that means whether this 10 mod 5 is it equal to 0. Okay, so that means divide 10 with 5 and check the remainder. So then the remainder is 0 here, remainder is 0. Yes, true. Then return a, what is a value? 5. So 5 value it returns to the main function. Okay, so that 5 value comes here. Again return means from here the value 5 will be returned to the main function. That's how the recursive execution happens. Got it? Okay, so with these three lines you can uh, calculate GCD of any two numbers here. Okay, so then after you write the main program here. Okay, so this could be your main code here. Okay, so what is the main code? That means you need to take two values and you should call this function. Okay, so I am just calling the two function, or directly you can call this function. Say for example, a value is something like 10, b value is 15. Okay, so then I call the function and I directly print. Okay, so gcd is equal to, okay, so gcd is equals to, just you say, then comma, call the function gcd and pass a and b as a arguments. That's it. This is your program. So if you write such 6 7 lines of code, then no doubt you will be selected in interview, and you should able to explain what this logic, what is happening internally. Okay, so all these things you should able to explain to the interviewer. Otherwise, he understands that you have just by hearted the program and writing this code, because just it is 3 lines of code. Got it? Let us execute this code and let us verify whether our code works perfectly or not. Okay, so let me open online Python compiler. So this is our compiler. So let me increase the font size. Okay, so hope you can see. So let me type the code gcd, then a and b, two values I am passing here. Okay, so then I'll check here if a b mod a. Okay, so if it is b mod a, if it is equal to 0, then say return a. Okay, so otherwise this is not part of a if statement. Okay, so otherwise you should say return, call the same function recursively again, gcd of okay, so gcd of what you should say, you should pass the remainder as first argument. That means previous remainder becomes a value and previous a value becomes a b value. Okay, so that's it. Now you write your main code here. So this is our main code. So here we'll take a value as a 10 and b value as a 15. Okay, so then we'll directly call the function within the print function. Okay, so print and then say gcd is. Okay, so then say comma, call the function gcd and pass the two values a comma b here. Okay, so let us run the code and let us verify. Now you can see gcd is 5. So mathematically how we performed, okay, so in the same way it has calculated and return the answer. Okay, so let us change some values. Okay, say for example, if we take some other numbers like 12 and 15. Okay, so what could be the gcd? Now 3 is the gcd because 3 divides both these numbers. Okay, so like this you can test any number. Okay, so something like uh, 18. Okay, so and something like 36 if I say. Now GCD is 18 here. Okay, so 18 to the 36. Okay, so if you give 16 here, now you can see the GCD is 4. Okay, so 4 divides both of them. Greatest common divisor. Okay, so this way we can find, given any two numbers, we can find GCD, and you should able to define such kind of a function if asked. So in Python, always you prefer writing a function for a given task. It becomes easy to write the logic. Got it? Now, for example, see in this example, okay, so I'll show you what happens. What we did is we passed the smallest number as A and biggest number as B, then we are performing B mod A. We are dividing biggest number with smallest number. Okay. So instead of that, for example, if the let me just create some space. Now let us verify. Okay. So if I give big number first and smallest number next. Okay. So what happens? Let us verify here. We'll verify here. Okay. So we'll take these two numbers like this. Now, if I give A is equal to 5 and B is equal to 10, what happens in our code? Okay, so it should always, the biggest number must be divided with the smallest number. Okay, so otherwise you will get the quotient as a 0. Okay, so these numbers should interchange. Then only, because in our code always it is bigger number divided with a smaller number. Okay, in this case what happens, we'll see A15 B10. Okay, so if B mod A meaning is divide B with A. Okay, so divide B with A. Okay, so that means divide 10 with 15. Okay, so when you divide, what happens here? How many times? 15, 0 times. Okay, so then it 0, then you will get the remainder as a 10 here. So is it equal to 0? No, then it comes here again, the function will be called. Now look at this piece of code here, what is happening here. Okay, so the first argument becomes B mod A. B mod A, how much remainder we got? Okay, so we got the remainder as a 10. Okay, so that means now the first argument value becomes a 10 here. Okay, so then the second argument is A value. Okay, so A value is what? Previously 15. No? Okay, so this 15. Okay, so that means what is happening here? The numbers are interchanging. The numbers are interchanging. That means it is moving the bigger value to B and smaller value to A. Smaller value to A. Okay, so again the control goes up and again it tests. Okay, so when it is A, B, 10, 15, this is the process. That is how it is calculated, and we have seen it is returning the GCD value as a 5 here. Okay, so that means you can pass the arguments in any order. Okay, smaller number, bigger number. Okay, or bigger number, smaller number. Okay, or two same numbers, even two same numbers if you pass. Okay, so then it finds the GCD value and returns the GCD value. Okay, so sometimes in competitive coding, what happens means we concentrate only on this logic. That means smaller number first, bigger number next. But in test cases, sometimes bigger number first and smaller number second argument. If you pass, then your sometimes code may fail. In this case, it is not failing. Okay, but you should understand this. Okay, so it may fail here. So you should able to identify, if I give the bigger number first and smaller number next, whether my code gives the correct answer or not. You should check manually on paper, and accordingly you should modify your code. So hidden test cases are in this form. Okay, and your code will fail in such cases if you don't handle these cases properly. Hope you understood. So one of the application of this GCD, okay, so in one company's exam, it was asked, okay, so let us look at that code problem first and try to solve that problem. Now this is one of the problem given in competitive coding. Okay, so problem statement will be given like this. Okay, it will be some 6 to 7 lines, even 10 lines of a statement. Okay, it will not be asked directly like this sometimes. Okay, it will not be like this single line statement. Okay, so it is always 5 to 10 lines of a problem statement. Now you need to read the problem carefully and understand it. So little Robert likes mathematics. Today, his teacher has given him two integers. These things you should uh, underline very carefully. Okay, so his teacher has given him two integer and asked him to find out how many integers can divide both numbers. Okay, so teacher asked how many numbers can divide both these numbers. So can you find out how many those such numbers and tell me? That is what the question asked by the teacher. Okay, so now would you like to help him in completing his school assignment? Now the question is asked to us. Okay, so will you help him in completing his school assignment? That means you are asked to complete the assignment. Okay, so here the problem is not directly asked here. Okay, so you should understand the intention of the problem, what is trying to uh, find out from the problem. Okay, so it is to find out how many integers can divide both the numbers. Okay, so given two numbers, say like 10 15 you take, 10 15 you take. Okay, so given both these numbers, how many integer numbers, how many integers, okay, divide both these numbers, you need to calculate. Okay, so generally in brute force case, what we do? Okay, so if we apply the brute force method, what we do? We start from the first number onwards. Okay, so then we go on counting those numbers here. Okay, so we'll start whether one divides this number, one divides this number, yes, it divides, so count value becomes 1. Okay, so then we'll test 2 divides this, no. 3 divides this, no. 4 divides this, no. 5 divides this, yes. Okay, so one more number divided this, the count becomes 2 here. Okay, so then 6 divides this, no. 7 divides this, no. 8 divides this, no. 9 divides this, no. 10 divides this, no. 11 divides this, no. 12 divides this, no. 13 divides this, no. 14 divides this, no. 15 divides both of these, no. Okay, so like this you should go on continuing up to what number? So whichever is biggest, then you should find out starting from 1 to that number, go on dividing and count how many numbers divide both these numbers. So here how many numbers? These are the two numbers that divides these two numbers. So we got the count value as 2. Then we can say that two numbers. Okay, we don't want what are those numbers, we want how many only. Okay, so here only two numbers divide these 10 and 15. Okay, so that count value is 2. Given two other two numbers like 6 8. Okay, so then we need to count how many. Can you just type your answer in the chat? 6 and 8. So what we do? Whether 1 divides, yes. 2 divides, yes. 3 divides, no. 4 divides, no. 5 divides, no. 6 divides, no. 7 divides, no. 8 divides, no. Okay, so how many we got here? Only two numbers we got. Okay, so then the count value becomes a 2 here in this case. Like this, you should first derive some logic here. This is called brute force. That means starting from 1 to that number, we are go on checking. For example, if one of these number is some 10-digit number, you can imagine how much time it takes. Okay, so generally he gives a value, g value should not exceed like 10 to the power of 12 or something. Okay, this much big number. Uh, if you assign to A or P, how much time it takes for this brute force method. Now, if you observe from this brute force method, you should identify some logic here. You should identify some logic here. Okay, so this 1 and 5 we got here. Okay, and 1 and 2 we got here. Okay, we got here. Okay, so that means what we can do, we can reduce the number of times uh, dividing this number and checking whether it is divisible or not, dividing both or not. Okay, so how we can reduce, that means if this 5 is nothing but the GCD of these two numbers, yes or no, it is nothing but GCD of these two numbers. And if you look at this, 2 is the GCD of these two numbers, 6 and 8. For example, if you take 6 comma 9, okay, so then its GCD value is 3 here. Okay, so how you can make the calculation faster? That means after 5, just if you look at this, after 5, there is no number that is dividing both of these numbers. See here. Okay. Similarly, after 2, there is no number that is dividing both of these two numbers. Okay. That means it is sufficient to test up to GCD number. It is sufficient to test up to GCD number. No need to test remaining numbers for these. Okay, so that means given two numbers, if you can find the GCD number, okay, then start checking from 1 to that number. Already you know 1 divides every number. Okay, so this is already we known to us. Count value is 1. So just you start checking from 2 to up to its GCD. That means for this case, if you take you start checking from 2, 3, 4 and 5. Okay, check out up to this number. Okay, so even if you find GCD, okay, so you can avoid anyhow this GCD divides this. Okay, or you can check up to this GCD number 5. Okay, so to get up to this range, we require this GCD number. Okay, so go on checking from 2 onwards. 2 divides no, 3 divides no, 4 divides no, 5 divides yes. Okay, so 1 is already factor for every number. So now we will get that the number of divisors are 2. That's how. See here how many calculations you are doing. Just 3 to 4 calculations you are doing instead of 15 calculations. Now you reduced your number of calculations. This is how you should come up with some logic in competitive programming. Okay, so the input format is given. There are two integers a and b as input to the program, and output also given. Print the number of common factors of a and b. Both input values should be in a range. See here, 1 to 10 to the power of 12. That much big number you can pass to a and b. So if you use brute force logic, then your program may fail. That means you will be given a limited time for execution. If your program doesn't execute within that limited time, so you will get a TLE error. In competitive programming, we call it as TLE error, time limitation exceeded, time limit exceeded error. Okay, so that means your program taking more than sufficient time or taking more than allotted time to get the answer. Okay, so then online platforms won't allow such kind of execution. It immediately stops your program and raises this error, TLE error. Okay, so to avoid this, then you should come up with some programming logic here. That means you should able to solve the problem with best method. Okay, so all these things you can improve only by practice. Okay, so problem solving skills you should develop. by solving number of questions, practicing number of questions, writing code and testing such codes, you will able to develop such a skill, problem solving skill. Got it? Okay. So let us write the code for this. Okay. Convert the input into required output form. Okay. So let us write this code. Now you can see input 10, 5, output is 2. Okay. So that means what we required first for these two numbers. Okay. For these two numbers, we required need to calculate GCD of these two numbers. So for that, better you write a GCD function first. Already we have written that. Okay. So quickly once again I am writing this. So GCD I am calculating for A and B. Okay. So then how we performed, if B mod A is equals to 0, then what we did, we returned A value. Otherwise what we did, we return call the same function GCD. Okay. Then the first argument is reminder. It is nothing but B mod A, and the second argument is previous A value becomes now B here. That's it. This is your function. Yes or no? Okay. So that's why I asked you to write down these kind of functions. Okay. So if you learn writing such functions, it becomes easy for solving some complex problems. So once you get GCD, okay, so what you need to do, you need to identify the or find out a common divisors, number of common divisors you should identify. Okay, so let us take two numbers here. Say same A value is 10. Okay, so B value 15 I am taking. Now I have A and B values. Okay, so what I should take? I should take some count value here. Initially count value I should take as a 0 here. Okay, so then what I should do? I should uh, test up to GCD only. Okay, so GCD of these two numbers I should test here. Okay, so for that what you can do is you can get some variable g and call the function GCD. Okay, and pass this A and B values here. Then it calculates GCD of these two numbers and stores in a variable called as a g. So what is our g value now? G value becomes 5. G value becomes 5. Now you start sorry, count value you should initialize it to 1, because 1 already we know that 1 divides both these numbers. One factor is already known to us. Okay, so then we need to calculate only remaining how many factors. Okay, so that's why you should start uh, counting from 1 onwards. So count value you take as a 1 initially. Okay, so now you start checking from a 2 to 5. That means check with 2, 3, 4 and 5. Then you count. Okay, so that logic we need to implement. So to generate this sequence 2, 3, 4, 5, what we need to use? We need to use a for loop here. Okay, so for I in range, by using the range function, for I in range where from 2 to, okay, so 2 to up to G. So when you say range from 2 to 5, what kind of numbers it generates? It stops at before number I said. Okay, so then it generates the sequence like 2, 3, 4. It stops at 4 only, but we also want the 5 to be generated. Okay, so in such case what you need to do? You need to add plus 1 here. You need to add a plus 1 here. G plus 1. 5 plus 1 is 6. 2 to 6 means then it generates the sequence called 2, 3, 4, 5. This sequence is generated here. Got it? Okay. So once this sequence is generated, now you go on test. Each number divides both of these A and B or not. How do you test here? If okay, so how this for loop is executed? I gets the value. I initially first starts with a 2. 2 is passed to I. Now you test whether 2 divides both A and B or not. How do you test here? If A mod I is equals to 0 and b mod I. Okay, in Python for and we use a word called as and. This is and operator here. So b mod I is equals to 0. Okay, so that means if I divides both these numbers, okay, then that means you got one more factor, then you increment the count value. Okay, so then you can say count plus is equals to 1. The meaning is add 1 to previous count value. So now count value becomes 2 like this if it divides. Otherwise, what happens? It goes to the next number. If this is true, then only count value is incremented. Otherwise, it goes to the next number. I value gets next number, 3 it gets. Then it checks. 3 divides both these numbers, no. Then it gets the next number, 4. It checks 4 divides these two numbers, no. Then it gets the next number. 5 divides both these numbers, yes. Count value becomes now 2. Okay, that's it. All the numbers over in the sequence, then the for loop stops here. Now you can print here. After coming out from the for loop, you can just print here. Okay, so number of divisors. It is, the problem is simple application of a GCD. Okay, so that's how you should able to identify number of divisors. Okay, so where we have stored in a variable called as a count. If you print the variable count, it prints number of divisors as a 2. That's it. This is your code. Okay, so GCD is base for this problem. Any doubts in this? So shall we execute this? So let us execute this code. So already we have written the function. Okay, so that function already we have written. We make use of that function and directly will complete the code here. So main code I'm taking here 10. Okay, so let us take 16 and 36 itself for example. Okay, so then we'll find the GCD here. So you can take GCD. You can take a variable g. Okay, so g is equal to GCD of a comma b. It calculates. Okay, so now use the for loop for I in a range 2 comma g plus 1. Okay, so then you test whether I divides both these numbers or not. Okay, so if a mod I is equals to 0 and b mod I is equals to 0. Okay, so then you can see here, you can increment the count value. So count plus is equals to 1 you can say. Then after coming out from the loop, then you print the result here. Okay, so you print what he asked, number of divisors, no? Number of divisors. Okay, so common divisors he asked, number of common divisors. Then you can print the count value here. That's it. This is your code. Okay, so if you run the code, now there is an error. Okay, so name count is not defined. See, we have not defined the variable called count. Okay, so that's why after b you define the variable count and initialize it to 1. Okay, now if you run the code, now you can see number of divisors 3 here. Okay, so number of divisors are 3. So what are those 3 numbers for 16 and 36? 16 and 36. What are those 3 numbers? Let us verify those 3 numbers. Just let me show the screen. Right now. Okay, so let me show you what are those two number of devices what we got the number of devices as a 3 here. Okay, so let us see what are those three numbers here. Right, visible, right. Now for 16 and 36. Okay, so 16 and 36. Okay, so what is a GCD? So the GCD is 4 we said. The GCD is 4 we said. Okay, so then we'll test what numbers are dividing common factors. Okay, so 1 is already there. 2 and 2 also divides both of them. Okay, so then 3 divides no. Okay, so 3 divides them no. Then 4 divides them yes. So that's why we got the number of common divisors as a 3. Okay, so this is how you should able to verify your answer. Got it? So you can take any other two numbers and you can verify here. So instead of 16 and you can take some big numbers, okay, like say 54. Okay, so then again 36 if you take. Okay, so let us run the code and let us verify. Now this time you can see the number of divisors, 6 divisors you got. Okay, so what are those 6 divisors? You should able to identify such a factors. What are those 6 factors? Like this you identify manually. Then you can able to understand the logic, whatever logic you have written here, you should able to understand that logic. Got it? Okay, so this is how you should write code for a given problem in competitive coding. And what we do is we'll then this is another important problem. Okay, so this problem is also very important. Move all zeros to the end of an array while maintaining the relative order of non-zero elements. Okay, so given an array with zeros, what you need to do is you should move all the zeros to the end of the array. Got it? So how you can move all zeros to the end of the array? That is very, very important. So let us take one array and we will just test it. Okay, so manually we'll try to calculate first, then we'll implement the logic. Okay, so we'll take a simple array here. Say for example, from 0, 5. Okay, so then say 0, then 8. Okay, so then something like 12. Assume that this is our given array. Okay, so you should move all zeros to the end of the array, and all non-zero elements should be before those zeros. Maintaining the relative order of non-zero elements, you should copy in the same order. That means the number should appear like 1, 5, 8, 12 only. Okay, you should not change this order. After that only the zeros should appear. This is the answer. Okay, so your answer should look like this: 1, 5, 8, 12, then 0, then 0. This is how your array should look like. We moved all zeros to the end of the array. Okay, so this is what asked. Now how we can achieve this? How we can do this? How we can move? That means no doubt we need to traverse the array. We need to visit each element of the array once. Okay, so while visiting, what we need to do? Whenever we encounter a non-zero element, we should move that non-zero element to the beginning of the array. Not beginning, that means at the starting portion of the array. Okay, and the zeros we should move to the end portion of the array. How we can achieve that? How we can achieve that? Okay, so that means we'll try to derive some logic. Assume this is our array: 1, 0, 5, 0, 8, 12. Okay, now first I start scanning. I encounter 1 here. It is a non-zero number. That's I don't disturb this. Okay, so that means what I need to do? I need to scan the array. Initially, I start with the I value. Okay, so I is equal to 0. Okay, yes or no? I traverse the array here. Okay, so first I is equal to 0. So 0 index element I'll test here. So it is non-zero. Okay, so non-zero means, okay, so don't disturb the array. Don't disturb the array. That means no operation, you can say. No operation. No movement of elements here and there. Okay, so next I'll go to I is equal to 1. I is equal to 1 means I encounter 0 here. I encounter 0 here. Okay, so then what I should do? I should move this 0 to the end of the array. Instead of moving 0 to the end of the array, okay, that also you can do. You can just swap end of number with this number. But what happens? The order will not be maintained. 12 comes here, 0 goes here. If this point is not given, okay, if this point is not given, you can simply swap last numbers with zeros. That's it. Over. But he is asked to maintain the order. Okay, so that means you cannot swap with the last number. You cannot swap with the last number. Okay, so what you need to do now, at this 0 position, if there is any non-zero number after this, that non-zero number should occupy this and 0 should go to that place. Yes or no? Okay, so for that position, for that what we do is we use a variable called as a position. We use a variable called as position. Position indicates the position of the non-zero number to be swapped. Into which position it has to be swapped. In this case, the position value is 1 here. Position value is 1 here. Okay, then we'll keep track of this I value here. Okay, so I is equal to 1. I is equal to 1. Okay, so it is a 0 value. How we start then? How we start initially? We start how we should change this position value. That means initially we start with the position as 0, position as a 0 here, and we start traversing the array from the first element I is equal to 0 here. Okay, so if it is a non-zero element, okay, if it is a non-zero element, okay, so that means we should move to the next element. We don't do any operation here, no operation is performed, simply we increment the position value. Okay, so whenever there is 0, only that 0 has to be swapped with other non-zero numbers. Zeros only must be swapped. Okay, so that means no operation and increment the I value. That means whenever we encounter a position non-zero number, okay, so we don't do any operation, or even if you can do operation, nothing will happen here. Okay, so that means we swap the number at position 0 with a position value, these two values, but here I0 and position 0, that means one swapped at 1 only. Okay, so that means no change operation, no operation or no change occurs here. Got it? So simply after that, then you increment the position value. Position value becomes 1. Now this is the position value where the next non-zero number has to be placed or swapped here. Okay, so then I value becomes 1. I value becomes 1. Then we'll test here. Is it a non-zero number? No. Is it a non-zero number? No. Okay, so just uh, don't do this. Then go to the next element. I value becomes 2. Then it checks, is it a non-zero number? Yes. If it is a non-zero element, then you swap this. For example, if this is your array, okay, so then you interchange this with a position value. That means move this non-zero number to this position where POS value is present. Okay, so that means I move this 5 to this position value. Okay, so 5 should come here and 0 should go here, so that I am moving zeros towards right here. Okay, so that swapping should upper. So then swap what? Swap a of position value, a of position, and what other number you need to swap? A of I value. These two values are swapped here. Okay, so once swapped, what is the resultant array you will get here? I remove this, then your resultant array looks like this. Your resultant array looks like this. Okay, so then 5 comes here, then 0 comes here. Okay, so then once you swap here, now the position of next element to be swapped should increase. Yes or no? So the position value should point to the next element here. Okay, so that's why after this, what you do, you increment the position value. So position value now becomes 2 here. This is the position where you need to swap. When you swap, obviously in the next position it is 0 only. Don't worry. Okay, so if it is not a 0, how it is, or you can ask. But when you are swapping these side by side numbers, automatically 0 come. When you are swapping means you are moving 0 towards right only. That's it. Okay, so position value now becomes 2 here. That means this is the next non-zero element position to be swapped here. Okay, so then I value becomes 3 here. Okay, so 0 1 2 3, it is a 0. Okay, so don't do any operation here. Then I value becomes 4 here. Okay, so it is a non-zero element. Now you need to, for non-zero element, what are the operations? These are the two operations you need to perform. Okay, so you need to swap a of position and a of I. Okay, so which numbers to be swapped here? Now you need to swap. Okay, so a of position, a of position and a of I value, these two need to be swapped. So a of position is what? 0. Okay, so a of position, what is position value? A of 2. This element should be swapped with I value. What is I value? 4. This is swapped here and this is swapped here. Okay, so if you swap these two, then what is the resultant you will get? Then the resultant array looks like this. Your resultant array looks like this. So 8 comes here. Okay, then 0 goes here. Then what happens? You need to increment the swap value or position value. So position should become a 3 plus 1. Okay, so position comes here. This is the position where the next non-zero element to be swapped here. Okay, so the next I value becomes 5 here. So then is it a non-zero number? Yes, non-zero number means again swap here. Okay, so which two numbers you need to swap? You swap this and this. Okay, so when you swap, what happens? Just see here. So 12 comes here. Okay, so 12 comes here and 0 goes here. 0 goes here, and this is your position value. Position value now should increment to the next one. Okay, so position value becomes 4. Okay, so I is equal to 5 we reached. That means how many? 1, 2, 3, 4, 5, 6 elements are there. Okay, so 0 to 5 means we traversed all the elements, then the loop terminates. Okay, once the loop terminates, now your array looks like this. This is your array. This is how your array looks like. Now just look at the array. So the numbers are arranged, non-zero elements arranged first, then followed by zeros. Zeros moved to the end of the array. Yes or no? Got it? Okay. So this way, you should devise some logic on paper. Okay. So you should work out on paper like this. And whenever you get logic, you should implement that. You should test whether it is working for other numbers also, whether it is fine with other numbers. Is it moving zeros properly, non-zero elements properly to required position? See, we also maintained the order 1582. 1582 is the order. 812, sorry. Okay, so this one now we need to implement in the form of a program, right? Shall we write program for this? So this is called as a two pointer approach. This is called as a two pointer approach. One pointer keeping track of the position here. Okay, position is called one pointer. Here I is called another pointer. Okay, so we are tracking each element, non-zero element position by using I, and the position where to be swapped by using a variable called as position. Okay, so that's why it is called a two pointer approach. We call it as two pointer approach in competitive programming. Okay, so now what we do is simply we will implement this in our code. Okay, so now we write a code for this. Okay, right? So given an array, directly I write the main code, very small code here. So what we do, we define an array here. Array is implemented as a list here. No, so what we can do, 1 0 5 0 8 12. Okay, so this is our array. So what we required here, one pointer is required for monitoring the position. So you can say position is equal to initially 0 here. Okay, so then you traverse the array to the length of the array here. So how you can traverse? By using a for loop. So for I in range, for I in range. Okay, so how do you get the number of elements here? By using the length function here. Okay, so length of the array here. Okay, so it length of the array is what here? 6. Okay, so range 6. When you say range 6, it generates the sequence like 0 to 5 it generates. This is the sequence generated. Okay, so it generated this sequence. I value takes these 6 values, 0 1 2 3 4 5 6 values. Okay, so that is what generated here. Okay, so once you have this, for each number you need to test. Okay, if it is a non-zero number, then only you should swap. Okay, so how do you test? How do you test? If a of I, if a of I, okay, so how do you know that it is a non-zero number? If it is not equal to 0, then you can confirm that it is a non-zero number. Simple. If a of I is a non-zero number, okay, so what you need to do, you need to swap. Okay, so in Python it is very easy to swap the two numbers. Okay, how you can swap? For example, a value is 10, b value is 20. Okay, in Python how you can swap is, you can swap like this: a comma b, Okay, so A comma B equals to B comma A. That's it. The two numbers will be interchanged. 20 goes here and 10 comes here. And if you print A and B values, A value becomes 20 and B value becomes 10. With this single line, you can swap. This is allowed in Python. Simply you can say A comma B is equal to B comma A. That's it. Got it? Okay. So now you need to swap from this position onwards. Okay. So how do you swap here? How do you swap? So which two numbers you need to swap here? Just see here. A of position and A of I value you need to swap. Okay. So now you should write here. You swap A of position comma A of I is equal to, okay, A of I, reverse you should write here. A comma B is equal to B comma A, no? So it is A of I comma A of position. That's it. It's just like A comma B is equal to B comma A. A of position comma A of I is equal to A of I comma A of position. The numbers will be interchanged like this. Okay. So these numbers will be interchanged. This is position and this is I value. The numbers will be interchanged. Okay. So what we are doing here? We are performing the swap. If the condition it is a non-zero number, then you swap. After swapping, what you need to do? You need to move the position value. Okay, you should increment the position value. Okay, so that means already one non-zero number we moved to position. So you should go to the next position here. So you should say position plus is equals to 1. Position plus is equals to 1. That's it. Okay, so this is your code and it repeats for all the non-zero numbers. It changes the array value. So after coming out, if you print the array value, if you print, okay, so new array, just you print a new array, okay, or modified array, something like comma, just you say A here, then the array will be printed here. That's it. Just 4 5 lines of code it is. The thing is, if you understand, if you find a logic, then it becomes easy to implement that logic in the code. Yeah, quickly, shall we implement this? Say yes, shall we implement this? Okay, so let us open the online compiler. I remove everything. Okay, so let us write an array here. The same numbers will take 1, 1 comma 0 comma 5 comma 0 comma something like 8 comma 12. Okay, so you can give any number of elements here into the array. You can pass any number of elements into the array. Okay, so what else we required? We required some position. Position is equal to initially 0. Okay, so then use a for loop here for I in range of length of the array. Okay, so then you check each number. If a of I, if a of I is a non-zero number, if a of I is a non-zero number, okay, so then a of I is a non-zero number, you need to perform the swap here. Okay, so swap the numbers. Swap the numbers. Okay, so which numbers you need to swap? A of position, comma, a of I value should be equal to a of I, comma, a of position. Interchanging happens. Then immediately you increment the position value. Plus is equal to 1. That's it. Okay, so after coming out from the loop, you print the new array. Okay, so something like a new array. Then say comma a value you print. That's it. Okay, so if you run the code, let us see, you can see 1 5 8 12 0 0. Okay, so I'll modify this, say for example comma one more 0 I put here. Okay, so then I give again one more zero I keep here. Okay, so then I write something like 55 here. Then again we'll let us run this code. Now you can see four zeros moved to the end of the array. Okay, while maintaining the order. So this way you should able to write some logic, okay, and write the code and test your code. Got it? So if you work out such kind of problems, okay, so it becomes easy to implement the logics for complex problems. Start learning or start implementing such kind of programs and improve your problem solving skills. This is what required, especially in programming. Companies are looking for people who has good problem solving skills and programming skills. So friends, if you found this video useful, so and hope it would help to improve your problem solving skills. So if you think on those lines, please like and share this video. And if you are new to this channel, so please subscribe to the channel and also turn on the bell icon for more notifications and updates. So thank you one and all. Happy coding.